All right, today we're going to be looking at equations of linear relationships. And so let's first of all review two properties of linear relationships. First of all, each has a starting point when the independent variable equals 0. We always think of the independent variable as the x, and we graph it on the x-axis, but it could be a different variable. It could be t for time. It could be a lot of different things, but so we think about it when x is 0, but in general, it's when the independent variable is equal to 0. And the second thing is that the graph is a line. And remember, we mean a straight line, but we don't have to say that. That's where it gets the name linear. So here we have a graph, a straight line, and this is the independent variable is x. When the independent variable is 0, that's when we're on the y-axis. And so right there is our starting point. So let's label that with the letter B. Traditionally, we use B for the starting point. And let's label that starting point. And if we put both coordinates here, our x is 0, and then B is where we start, our starting value. Now we can also show the slope. What makes it a linear equation is that there's a linear relationship, there's a constant slope. That's what makes a straight line. And so I can choose any 2 points, and if I go around the block from one point on the line to another point on the line, I'll get a triangle that's proportional to m over 1. So the slope is m, also called the rate of change, and we calculate that as change in y which is in this graph is m over change in x. So no matter how I draw my triangle, it's always going to equal a ratio. It will have an equivalent ratio to m. Equation, now that's all pretty much review. What's new is what we're going to say next. So let's scroll the page. So the equation, there's two common patterns that we can have for the equation of a linear relationship. Y equals b plus mx, or y equals mx plus b. And the starting point is always going to be the b. So if I'm using this pattern, my starting point is right there. If I'm following the second pattern, my starting point is there. The starting point is always going to be a number by itself. So we'll see that in a second. And then the slope will always be multiplied by the x, whether it's at the end of the equation or at the beginning. If the starting point is 0, then the relationship is also proportional. It's still linear, also proportional, because the graph will go through 0, 0. So in this case, b is equal to 0. And so the equation becomes y equals b plus mx, or 0 plus mx, which we can rewrite as y equals mx. But for a proportional relationship, we usually write y equals kx. So these are all equivalent. It's kind of annoying that for proportional relationships, we use a k. For non-proportional, we use an m, but it's just a letter. In this case, m stands for slope. In this case, k stands for constant of proportionality. But in a proportional relationship, the slope is still equal to k. So they're just equivalent ways of saying the same thing. All right, let's look at an example, just like we did in our Desmos, where we're stacking cups. We have two variables. N is the number of cups, and h is the height of the stack. And if you look at the graph down below, you can see here we're putting height on the y-axis. In other words, we're saying that the height of the stack depends on the number of cups. So you tell me how many cups, and I will tell you the height of the stack. So that makes the number of cups independent. So we're going to choose the number of cups. It's independent. And then the height will depend on whatever we choose. So if we look at this diagram, we can see here the starting height is going to be when the independent variable is 0. So if I have 0 cups, my model still has a height of 5 centimeters that comes from this base. Of course, nobody would ever make a stack like that, but that's what the model of our equation represents. And then every time I add a cup, I'm going to add 0.9 centimeters to the height of my stack. So that's adding 0.9 centimeters per cup. So the equation then is going to follow, I'm going to use the pattern y equals b plus mx. And in this case, instead of y, we're going to use, instead of x and y, we're going to use n and h. So h is the dependent variable. So the height depends on the number of cups. So I'm going to replace the y with an h. B is my starting height, so that's going to be the 5 centimeters. I don't need the units, just 5. M is my slope, or rate, so that's going to be 0.9. And x is going to be my independent variable, so in this case, that's going to be n. So my equation is h equals 5 plus 9/10 times n. If I use the other pattern, I get h equals 9/10 n. Whoops, not x. 9/10 n plus 5. And so either one of those equations is fine. Okay, let's scroll again. And now we're going to make the graph. So let's start with our starting point. So right here, the starting point is going to be 5 centimeters. So let's label that with a 5. We know that the graph goes up because the height gets taller as I add cups. And then I'm going to show the slope by choosing 2 points. And I know that this triangle is going to, every time I add 1 cup, the height is going to go up 0.9 centimeters. All right. Let's go to the next page. All right. Leah measured the snow during 2 storms, one after the other. So in this graph here, we have 2 storms. First question is, how long did storm number 1 last? So we're going to look at that point right there, which is the end of storm 1, and we see that it lasted 9 hours. So storm 1 lasted 9 hours. Second question asks, why does the graph for storm 2 start here at 0.6? So if this was a normal timeline, then the depth of the snow would increase during storm 1, and then it would remain steady, and then when storm 2 started, it would start going up again. But this is not normal time. This is time since the start of each storm. So we're going to start over at 0 for storm 2. So this 6 inches is what was left from storm 1. So there was already 6 inches of snow from storm 1 when storm 2 started. And that's why this starts here. By defining our time this way, we can compare the 2 storms on the same graph. Which storm had a higher rate of snowfall? That's going to be storm 1 because its graph is steeper. All right, let's fill in our table. So I'm going to just repeat the graph from up above. You can look at your own notes. So for storm 1, the starting point is right there at 0, 0. And to calculate the slope, we're going to choose, well, first of all, please write the formula here. Slope is change in y over change in x. So let's choose these 2 points, and we're going to go around the block. I'm going to go up first and then to the right. And here I'm going up from 4 to 6, so that's a change of 2. And I'm going from 6 to 9, so that's a change of 3. So my change in y is 2 inches. My change in x is 3 hours. And so that gives me, if I separate the numbers from the units, I get 2/3 of an inch per hour. So what does this slope mean? It means that 2/3 of an inch of snow falls every hour. Next question asks, is this relationship proportional? The answer is yes, because the graph is a straight line through 0, 0. That's how we know it's proportional. And so for the equation, I'm going to follow the pattern y equals b plus mx, but I could have done a shortcut if I thought about this. And b is going to come from here. The starting point is, remember the starting point, let's remind ourselves, is 0b. And so that means b is 0. So I get y equals 0. M is the slope, 2/3. So y is 0 plus 2/3 x. Now, a shorter way of writing this is just y equals 2/3 x. And again, I could have gone straight here if I thought about, oh, it's a proportional relationship. Let's do storm 2. We already know the starting point is here at 0, 6. Let's calculate our slope between these 2 points. So here I'm going, my change in y is from 6 to 7, so that's a change of 1. My x is going from 0 to 4, so that's a change of 4. So I get a slope of 1 inch per 4 hours, or 1/4 of an inch per hour. So that means 1/4 of an inch falls every hour. Is this relationship proportional? The answer is no, because the line does not go through 0, 0. And let's make some room here to write the equation. So again, we'll say y equals b. B is here, 6 plus mx. M is 1/4. So I get y equals 6 plus 1/4 x. Or if I use the other pattern, I get y equals 1/4 x plus 6. And those are both good. Okay, let's put this into practice. We're going to start with an equation, and then we're going to use it to sketch a graph. So the first thing that we want to do is figure out which pattern of equation are we following. So remember back in, what page is this? 17, I think. We introduced the equation. We had 2 patterns, y equals b plus mx and y equals mx plus b. These are both called the slope-intercept form because we see the slope m and the y starting point or y-intercept b in each one. So first thing we're gonna do for each of these problems is we're gonna look at the equation and see which pattern doesn't match. And for the first couple, I'm gonna read them both to you. So does this match y equals b? And pay attention to where the x is. Y equals b plus mx, the first one, or does this match the second one, y equals mx plus b? It should be clear we're matching the first one, y equals b plus mx. So we're going to write that underneath. And then it's very easy to see that b is 10, which means that the y-intercept is 0, 10. And m is 3/4, which means that, let's graph that actually. So 0, 10 is here. Draw a little tick mark, label it 10, and put a dot. point, graph a point. Then the slope is m. We want to remember that slope is change in y over change in x. We're going to need that. And in this equation, by matching this pattern, we can see that m is equal to 3/4. Because change in y is either up or down, the y-axis goes up or down, and this is a positive 3, it means we're going to go up 3. Change in x, the x-axis is right-left, and because this is a positive 4, it's going to be to the right. So to find another point on the line, we're going to start here, and we're going to go, first of all, hold on. I want to sketch my line, so I'm going to ask myself, is this slope greater than 1 or less than 1? 45 degrees, I get a 45-degree angle for a slope of 1. So this is less than 1, so I'm going to draw my slope less than 45 degrees. Then I'm going to draw a slope triangle. From the intercept, I'm going to go up 3. And please label the 3 on the inside of the triangle so we don't get it confused with the coordinates here. Oops. Up 3 and 4 to the right. And I actually wanted to include little arrowheads here to show the direction that we're moving. So we went up 3 and 4 to the right. Ooh, no, that's not what I wanted. Okay, so now, if I started at 10, and I changed by going up 3, 10 plus 3, my new coordinate is 13, so that's the y-coordinate for this point. And my x-coordinate is going to start, actually it's starting at 0, and then I go from this point here has an x-coordinate of 0. From here, I go 4 to the right. 0 plus 4 is 4. So the coordinates of this point here is x is 4 and y is 13. The last thing we want to decide, is this relationship proportional or not? It is a straight line, but it does not go through 0, 0. So this relationship is not proportional. All right, let's look at the next one. We're going to move this. All right, does this equation follow the pattern y equals mx plus b, or y equals b? I said those in the wrong order. Number 1, y equals b plus mx, or y equals mx plus b. It matches the second one, y equals mx plus b. And so my b is here. So the y-intercept is 0, 3/4. Remember, for the y-intercept, x coordinate is always 0 because we're on the x-axis. So let's graph that point. It's going to be just up a little bit, 3/4. And then that means my slope, m, is going to be 10. And we like to write it as a fraction for this, so I'm going to take that 10 and make it 10 over 1. 10 over 1 is more than 1, so my line is going to be steep, very steep. And then from here, we're going to go up 10 and 1 to the right. So let's draw that. Again, put the 10 on the inside of the triangle. The 1 can go above. So if I'm at 3/4 and I go up 10, now I'm at 10 3/4. And if I'm at 0 for this point, x is 0, and I move 1 to the right, I'm at 1. So the coordinates of this point is 1, 10 3/4. It is a straight line, but does not go through 0, 0, so it also is not proportional. Now this one here looks different, right? So what I'm going to do is I can always add 0 without changing the value, and this will help us match our pattern. So y equals mx plus b, or y, sorry, I'm doing that wrong. Y equals b plus mx, number 1, or y equals mx plus b, number 2. It matches number 2, y equals mx plus b. And here we can see that b is equal to 0, so our y-intercept is 0, 0. Now, you didn't have to add the plus 0, and maybe you would have said, look, this y equals 7/3 x, that matches y equals kx, so I know it's proportional, so I know the y-intercept is 0, 0. That would be another way to get the same answer. The slope, I can see, is 7/3, because that's greater than, meaning we're going to go up 7 and 3 to the right. This slope is greater than 1, so I'm going to draw a steep line, steeper than 45 degrees. And from here, we're going to go up 7, 3 to the right. So if I start at 0 and I go up 7, I'm at 7. And if I start at 0 for the x and I go 3 to the right, I'm at 3. So my new point here is 3, 7. I have a straight line that does go through 0, 0, so this relationship is proportional. And finally, y equals -3 plus 2x. So does that follow y equals b plus mx, or y equals mx plus b? It follows, actually, we're going to change that 2 to a 5. It's going to work out better for the graph, so let's change that. So, which pattern? It follows y equals b plus mx. So again, b is -3. So the y-intercept is 0, -3. The slope is 5. Oops, let's graph the y-intercept. So down here at 0, -3, it's below the x-axis. The slope is 5, which I'm going to write as a fraction, 5 over 1, which means go up 5 and 1 to the right. So that's pretty steep. And in particular, if I start at -3 and I go up 5, I'm going to go past the y-axis. So my slope triangle is going to go past the x-axis. Again, label the 5 on the inside. If I start at -3 and I go to the x-axis, that's a jump of 3. I need to go 2 more, so that leaves me at 2. So my slope triangle is up 5, 1 to the right. To go up 5, I go up 3 and 2 more. 3 plus 2 is 5. And then 1 to the right, so I'm going from x equals 0 to x equals 1. So the coordinates of this point here is 1, 2. And again, we have a straight line that does not go through 0, 0. So it is not proportional. Okay. All right, example 3, we're doing some online shopping. So Ms. Moran wants to buy chocolate bars online. One store charges $6 per bar. Actually, we're going to change that. We're going to change that to $4 per bar with a flat fee of $20 for shipping and handling. And our question is, what is the total cost for 5 bars and for 10 bars? So to buy 5 bars, I'm going to take these 5 bars, multiply by $4 per bar. Notice that these bars kind of cancel out. Bars here in the numerator, bars here in the denominator. That leaves me with 5 times 4 equals $20. But to that, I have to now add the flat fee for shipping. Let's actually circle that. And so $20 plus 20 more for shipping is $40. I'm paying half for shipping. So when I graph this is going to be the point 5, 40. when I buy 10 bars, the only thing that changes is this part. So I'm going to take those 10 bars, still multiply by $4 per bar, which gives me $40. But now I'm going to still add $20 for shipping, and so that gives me $60. So this is the point 10 comma 60. Now I want to write an equation to represent the total cost y to buy 6 chocolate bars. So the easiest way to do this is to follow what we did. So x is the number of chocolate bars. So that's this first thing. What did I do first? I multiplied my x times $4 per bar. So that's going to be... Actually, I don't even want to do that. So that's going to be $4 per bar times x bars. And then I add the $20. And this is a time when the pattern y equals mx plus b is easier to use. Because what did we do? First we multiplied times our rate, and then we added our starting point. Now we want to make a graph of the cost of purchasing up to 20 bars. So that means, let's figure out how much 20 bars would cost. That'll help us make our graph. So I'm going to take my equation and replace x with 20. So y equals 4 times 20 plus 20 for shipping. So that's 80 plus 20 equals $100 for 20 bars. So that gives me the point, 20 comma 100. Okay, our independent variable y is the total cost. This is what it says here. Let's circle that. And x is the number of chocolate bars. Now, my number of bars has to go up to 20, so I'm going to count 1 bar per line, but I'm not going to write... No, I'm sorry, I have to count 2 bars per line, and I'm not going to write each number. It's too crowded. So this is 0, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. For the total cost, I'm going to go $10 per bar, but I'm only going to write every other number, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Then I'm going to start with my flat fee at 0.20. That's my starting point. Then I'm going to graph this point at 5.40. So 5, this is 4, this is 6. So the 5 is halfway between 4 and 6 and $40. 10 comma 60. 10 is this line here between 8 and 12 and 60. And 20 comma 100. The 20 is here. The 100 is there. All right. And draw our line. Use a straight edge to draw your line, and we're going to label that store number 1. Okay, let's scroll the page. All right, next. Another store charges $7 per bar, but shipping and handling are free. So we're going to write an equation for this one. So this $7 per bar, that per bar tells me that's the rate or the slope. Shipping and handling are fee tells me there's no head start or no starting point, so B is going to be 0. So if I do y equals mx plus b, I get 7x plus 0, or just y equals 7x. So I can see here my y-intercept is 0, 0. And then what if x equals 10? Then I'm going to multiply 7 times x is 7 times 10, so y is 70. So my second point is 10 comma 70. So let's graph those 2 points, 0, 0, and 10 comma 70. So again, the 10 is here between the 8 and the 12, and 70 is this line here between the 60 and the 80. And then draw a nice straight line and label that store number 2. This last question, we're gonna adjust it. Which store would you use to buy 16 bars? And we're gonna use our graph to estimate this. So I'm gonna look at 16 bars. I'm gonna look at both lines. And I see here that for 16 bars, store number 1, that's the wrong number, costs about 80, halfway between 80 and 90, so about $85. It's just an estimate. But that's from my graph. And then for store number 2, 16 bars is going to be right about $110. And so clearly I would use store number 1 because it costs less. Oh, shoot. That should not be 90. So $85 is less than 110. Now we're using our graph to estimate. Those aren't the exact values, but it's all we need. It tells us everything we need to answer the question. And that's it for these notes.